Hello, welcome to the lecture series on automobile engineering. In this session, let us discuss about fuel injection in petrol engine. In the previous session, we have discussed about carbureted engines. Now, the present day technology is fuel injection. So let us understand that. I have shown a schematic of petrol injection system. In this system, there is a fuel injector. Is the inlet manifold, is the intake valve or suction valve. Here we have the throttle valve. Then air intake system is shown. So the air enters this way into this air. Before the air entering into the engine, the fuel is injected and the air fuel mixture enters into the engine cylinder during the suction stroke. How much fuel should be injected? So that will be decided by the electronic control unit. So this will decide the pulse width and accordingly the fuel gets injected. Okay, the fuel will be coming from, as I explained earlier, a fuel tank, then fuel pump, then there is a pressure regulator valve to regulate the pressure of the fuel, and accordingly the fuel flows and enters into the injector. So let us discuss about such a system. For petrol engine, so we can classify fuel injection system as port injection. In that, continuous injection, timed injection we have. Then we have gasoline direct injection into the cylinder, that we call it as GDI. Then there is manifold injection system. Again, in that we have continuous and timed. Then also we have multi-point fuel injection system. Multi-point fuel injection. So in that, again, port injection, throttle injection. Let us look at all these types. So port injection sprays fuel into the intake ports where it mixes with the incoming air. The injectors are usually located in the runners of the intake manifold. When the intake valve opens, the fuel mixture is pulled into the engine cylinder. So here we have shown the fuel injector. This is the port. Into this inlet port, the fuel is injected. So the blue colored one is the air, the yellow colored one is the fuel. This is injected. And during the suction stroke, as soon as the valve opens, this air fuel mixture enters. In the manifold injection, you can see here we have multi-cylinders, 1, 2, 3, 4 and all. There is one single injector. Air enters into this manifold and into this air the fuel is injected. Then it is distributed depending on the suction stroke of that particular cylinder. Okay, then we have direct injection. Here you can see the cylinder. So injector is mounted right above this at the inlet valve. Through the inlet valve, air enters. Then into the cylinder, the fuel is directly injected. That is direct injection system. So you can note the difference between port injection, manifold injection, and direct injection. So there is something like we use the word continuous versus timed injection. Continuous fuel injection system provide a continuous spray of fuel from each injector at a point in the intake port located just before the intake valve. Because the entrance of the fuel into the cylinder is controlled, entrance of the fuel into the cylinder is controlled by the intake valve, the continuous system fulfills the requirement of a gasoline engine. Timed fuel injection system for gasoline engine inject a measured amount of fuel in timed bursts that are synchronized to the intake strokes of the engine. Timed injection, it is timed. Timed injection is the most precise form of fuel injection, but is also the most complex. In this, there are two basic forms of timed fuel injection. One is mechanical and the other one is electronic. The more common type of timed fuel injection is the electronic timed fuel injection, and it's also known as electronic fuel injection. In short, we represent it as EFI. Now let us understand what is the meaning of single and multi-point injection gasoline engines. You can see here there's a multi-cylinder engine, but you have only one injector here. This is the throttle. Air enters into this manifold. Into this, the fuel is injected. Then the fuel is distributed to the different cylinders. So it is single port injection. As you know, there are many complexities over here. Once the air fuel mixture is prepared here, the same quantity uniformly should flow into each one of the cylinder. So passage design is very, very important here. Okay, so that means sometimes different cylinders may get different air fuel ratios. That possibility is also there. Different quantities also a possibility. So to avoid this, you can have multi-point injection. In this case, for each cylinder there is one injector. Each cylinder there is one injector. You can see there is a common rail. So now once the throttle is open, the air enters. Then it gets into the inlet port of a particular cylinder. Into that particular cylinder inlet port, the fuel is injected. So we are injecting fuel at multi-points. So it's a multi-point injection system. So it is more controlled over here. So we can maintain the right air fuel ratios. Okay, this is injected as per the firing order, maybe 1 4 3 2 or 1 2 4 3, like that, depending on whatever firing order we would maintain. Accordingly it will be injected. In this, as I mentioned, it is direct. Here it is injected in the port, you can see there, but here it is directly injected into the engine cylinder. So that is a direct injection system. Multi-point fuel injection They further classify into two systems, DMPFI and LMPFI. DMPFI is referred to as D-Jetronic. Okay, this is a trademark of Bosch. D-Jetronic is a word created from the German word Druck, means pressure, and Jetronic, a word coined by Bosch, means injection. It works as a manifold pressure control type. So you have the engine over here, intake manifold. Then at the intake manifold you have the injector, and the ECU will control depending on the pressure ECU, what is the vacuum it will sense, and based on that it will decide what should be the quantity of fuel, and it is injected. So that's how it is manifold pressure control. Another one is LMPFI, is referred to as L-Jetronic. The L comes from the German word Luft, means air. It works as airflow control type. You see here the sensor measures quantity of air. Based on the required air fuel ratio, it will decide the quantity of fuel to be injected. In the previous case, it is based on the vacuum created. Here it is based on what is the amount of air that is getting into this. So that is what that is the difference between LMPFI system and the DMPFI system. So basically, if you look at MPFI system, you will have set of sensors, manifold absolute pressure sensor. Okay, see here, manifold pressure sensor is here. This system already I have explained. This is a complete air induction system. And what is the manifold pressure? That pressure will be measured by the sensor, and that sensor will send that signal to the electronic control unit. So it knows the pressure. Then throttle position sensor. You can see here the throttle position. That position, the sensor will send a signal to the electronic control unit. Then we have speed sensor, vehicle speed sensor. It is here. That also sends the information to the electronic control unit. Then you have coolant temperature sensor. You can see here coolant temperature sensor. That also will send the information to this. Then air temperature sensor. You can see here boost pressure temperature sensor. Here also sometimes they maintain here at this point also. So temperature sensor is there. That information will also made to flow to the electronic control unit. Then you have lambda sensor. Here it is nothing but oxygen sensor. This also, that information will be sent to the electronic control unit. So these are all the information the electronic control unit receives. So after that, ECU decides what should be the air fuel ratio, what is the quantity of fuel to be supplied. It decides the pulse width. Right, then how exactly, what angle the spark should be passed, whether it should be advanced, it should be retarded, it will decide. Then this will actuate the appropriate actuators, that is the injector basically. Then purge control solenoid valve, it has to open, which I've explained here. You have carbon canister, correct, purge valve, right, it will, whatever vapors are there, so they are also made to flow into the inlet manifold. Idle air motor, fuel pump relay, you can see here you have the fuel pump here. Then this is the pressure pump. Then again it will send a signal how long it should open, right, that is the signal that it is going to send it to this one. Okay, ignition coil, amperage ignition coil, yes, it also has to send a signal to ignition system when to spark. So these are all the actions it has to create. Okay, and of course this has to operate, means it has to be powered. This is how exactly the system works, and based on that the fuel is injected. It will calculate the right air fuel ratio and inject the fuel. So you can see now more uniform air fuel mixture will be supplied to each cylinder. No need to crank the engine twice or thrice in case of cold starting, as it happens in the carburetor system. I think there will be warming up. That facility is there. I have indicated in one of the diagrams. Provides immediate response in case of sudden acceleration or deceleration. Means it varies the air fuel ratio depending on the requirement. Since the engine is controlled by ECU, more accurate amount of air fuel mixture will be supplied, and as a result complete combustion will take place. Power delivered to the engine is better compared to carbureted system. Specific fuel consumption, SFC, is low and mileage of the vehicle improves, obviously reduces the emissions. So you can watch the video that's available on the YouTube, port fuel injection engine, and you will understand how exactly the whole system works. Now this is what I have shown, the injector, electronic fuel injection system. Now you have the solenoid valves which will pull this or release this. When you supply the power, it will pull this up. Okay, it will create a magnetic force and that it will pull, so that this will open up and then the fuel comes out. Fuel injection happens. As long as it is getting that electric signal, it will be in the open condition. Moment the supply is cut, this will close the valve. A fuel injector is nothing but an electronic controlled valve. Here you are getting the pressurized fuel anyway. Okay, it is capable of opening and closing many times per second. It depends upon how you supply the pulse, electric pulses to this. solenoid. Okay. So now the thing is how long it should open. This is decided by, that is what we call it as pulse width. This is base pulse width into factor A and factor B. So what is this? Suppose you would have chosen a base pulse width. Correct. Then, which is function, again, it is based on, say, engine RPM load. There will be a lookup table like this. Suppose you are engine 2000 RPM or something like that. So depending on what load and all that, it may choose a particular base pulse width. Let us say 2000 RPM load is 4. 2000 RPM load is 4. Okay, it may be equivalent to something like 8 milliseconds from the lookup table that is available, that it will decide. After that, let us say it also depends on the coolant temperature and oxygen level. So then it has to look at the A factor as well as B factor. Suppose coolant temperature equals 100 coolant temperature, then the factor A will be 0.8. Suppose oxygen level is equal to 3, then the factor B will be 1. Then what happens is it will go to this 8 milliseconds, then 0.8 of this, right here, and another one is 1. It will multiply and it will decide 6.4 milliseconds. Okay, then you see here 6.4 milliseconds to open. This is what we call it as pulse width. This can be varied. As you vary, the quantity of fuel injected will also vary. Okay, that's how the fuel injector works. As long as to maintain that pulse width, it will be sending the electrical signal. Accordingly, the injector will be opening and injecting the fuel. The advancement of MPFI, no, further advancement of MPFI is gasoline direct injection. Anyway, here the fuel is injected, as you have seen, only here, the inlet port. Now I am talking about directly into the engine cylinder. Intake stroke and see, fuel is injected directly into the cylinder during the intake stroke or compression stroke. High pressure injector required around 5 to 10 megapascals. Need bowl in piston design to direct the fuel spray towards the spark plug. That's the thing. Here, create the swirl motion into this. You are injecting the fuel. So this has different names: GDI, gasoline direct injection, fuel stratified injection, spark ignited direct injection, charged gasoline direct injection, and all that. And this also shows initially, see, this technology was like this: carburetor, then came the port fuel injection. Nowadays we are talking about the direct injection system. What is the advantage of GDI? Direct advantage of gasoline direct injection is the jump in fuel efficiency figures. Other is the reduction in pollutant levels. It does not affect the 0 to 100 figures to great extent, but since the engine can run under 3 different modes due to precise tuning that can be done, it makes it very dynamic. At low loads, the engine can run lean, stratified charge. So you have to understand the meaning of stratification, that wherever it's required, we pass the spark there, we maintain stoichiometric air fuel ratio, and all other places it will be weak mixture. And in case of moderate loads, it can use a stoichiometric mixture. In demanding situation like hill climbing and acceleration, it can even burn rich mixture. The biggest advantage that GDI offers is that the fuel can be injected multiple times during the single cycle. That's the thing. That's how it can manage the right air fuel ratio. The only thing is I've shown the injector directly mounted above the piston. Above the cylinder. Okay. So I think most of the things I have explained already. So you can read out. It's the repetition of whatever I have already explained with the GDI engine. So again, there's a video available from the Bosch. You can watch the video to understand the working of GDI engines. So that completes the fuel injection in petrol engines. So I think I have explained most of the technologies. But the whole question is, how do we create the lookup table? How do we program this? Correct. What are the various lookup tables that are required to do these? All these things we can study under automotive electronics. Here it's a technology subject. What are the technologies that are being used? That's the main scope of this course. So that's the reason why I have not gone into the details of those things. So if you are keen in those things, so many electronics, automotive electronics, fuel supply systems can be studied and understood. Okay, now thank you, and we will take up diesel fuel injection in the next video. Thank you.